Welcome to Creative World. In this video, we will solve Chapter 3 Learning Assessment E3.7. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Ohm's law. According to this law, voltage across any resistance R is the product of current through it and the value of resistance itself. Now move towards the problem. Learning assessment E3.7. Find the value of current I0 in given below figure using nodal analysis. This is the circuit diagram of given problem. Inside this network, we have to find the value of current through this branch labeled as I0 using nodal analysis technique. We know that in order to get the value of current through any resistance, we should have the value of voltage across that resistance. Then using Ohm's law, we can calculate current through that resistance. In this case, first of all, we will apply nodal analysis technique to calculate node voltage V0. Later on, we will be able to calculate current through this resistance because V0 is appearing across this 3 kilo ohm resistance. So first of all, we will apply nodal analysis technique. For that purpose, we have to follow some steps. The first step of nodal analysis technique is to count the number of nodes present in the network. In this case, there are two number of nodes present in this network. One is reference or ground node. Other node will be utilized for the implementation of nodal analysis technique. And because the number of non-reference nodes inside this network is 1, so there will be only one node voltage equation of this network. Second step includes to label node voltages. In our case, node voltage is already given in this scenario V0. In third step, we have to assume and label all unknown branch currents along with their directions. So current I1 and I2 are assumed through these two branches that are entering towards this node. Now we will apply Kirchoff's current law on this non-reference node. At this node, two currents are entering I1 and I2 while only one current is leaving I0. So entering currents are taken with positive sign while leaving current is taken with negative sign. In next step, we have to replace all these currents with their respective equations. Current I1 is equal to voltage across this 6 kilo ohm resistance divided by the value of resistance. The direction of current is entering towards this node. It means this voltage will be on higher potential than this node voltage. Voltage across this 6 kilo ohm resistance will be equal to the difference of voltage across this voltage source and V0. So the equation for current I1 will be 6 volt minus V0 divided by 6 kilo ohm. Here 6 is considered as higher potential than V0. Similar case will be applied with current I2. It is also entering towards this node. So this voltage potential is considered as higher potential than voltage V0. So the difference of voltage across 6 kilo ohm resistance will be 3 volt minus V0 divided by the value of resistance 6 kilo ohm. Similarly, current I0 is equal to voltage across this 3 kilo ohm resistance, that is V0 divided by the value of resistance 3 kilo ohm. Now, in order to further solve this equation, we will omit all denominator values. So, in order to omit all denominator values, we will multiply this equation on both sides with 6 kilo ohm. Product of 6 kilo ohm and 6 kilo ohm in denominator will cancel out with each other. Only 6 volt minus V0 will left. Same case will be applied here. Only 3 volt minus V0 will left. And here product of 6 kilo ohm will cancel out with 3 kilo ohm in denominator. 2 will left and that 2 will multiplied with V0. So it will become 2V0. Now add variables including V0 together. minus 2v0 minus v0 and minus v0 will become minus 4v0. Similarly, 3 volt and 6 volt will become 9 volt. Now place this minus 4v0 on the other hand side of equal to separate it from constant and make it positive. Divide on both sides with 4 to calculate the value of voltage V0, that will become 2.25 volt. As we have discussed earlier, after calculating the value of voltage V0, we are able to calculate current through this branch, that is labeled as I0. And it is asked to calculate the value of current I0 in this scenario. So using Ohm's law, we will calculate the value of current I0, that will be equal to V0 divided by 3 kilo ohm. Value of V0 is 2.25 volt. Divide 2.25 volt with 3 kilo ohm. Value of current I0 will be 0.75 milliampere. This was chapter 3 learning assessment E3.7. Thank you. See you again in next video.